Welcome to Dr. Goddard's lab. As you guys have probably already put two and two together, I'm Dr. Goddard. I'm a girl. My name is Madison. I often work up at the box office, but occasionally they let me come down here and blow some stuff up for you guys. Now, before we get started, if you guys would all take a second and please look up. You'll notice we are in a dome. That's because back in the 60s, this was the original planetarium. Actually, back in the 60s, this is all the Cosmosphere was this room right here. So we've grown a little bit since then, and as we grew, it's a new planetarium, one of which many of you guys will be at or have been at today. But then we still had this room we weren't sure what to do with. And we thought, we got rockets lying around, why not teach people how they work? So that's what we tried to do. But then came the predicament of what to name this place. Someone wanted to name it Dr. Tsiolkovsky's lab, after the great Russian scientist and teacher, Konstantin Tsiolkovsky, who back in the 1800s laid out all the groundwork for modern rocketry that everyone after him used. However, since he was just before his time, didn't have the funds, resources, or technology to make his ideas work, as important as he was, we decided not to go with him. Then came Werner von Braun, a German scientist, who actually did quite a lot. Built the first V2, the world's first spaceship, the Redstone rocket, which you guys can see out front, took the first Americans to space, and the Saturn V, which took the first Americans to the moon. Pretty impressive resume, right? So how come we didn't go with him? Does anybody know? We decided not to go with him because at a time he had hundreds of people working for him, and he always had enough money. So in the end, we decided to go with the American scientist who had it a little bit tougher, Dr. Robert Goddard, who at a time only had about 5 people working for him, including his wife Esther, and in the end, left us with 214 patents. Do any of the kids in here know what a patent is? Do you know what one is? No? Well, a patent, when you create something new, something never been done before, you get a patent on it. Then if somebody wants to use your creation, they have to ask you permission. Or better yet, pay you money. Dr. Goddard left us with 214 of those, which led to what we used to use, the space shuttle. The space shuttle actually retired in 2011. In fact, so boring, people actually stopped watching the shuttle launches. But back in the 60s, that never happened. You never missed a launch, because you never knew what was going to happen. And this, that was supposed to be our first satellite in space. That's actually Dr. Goddard's first try. So as you can see, some things are going to need a little bit of work. What we're going to do today is we're going to cover about 45 years worth of history in about 45 minutes. We're going to have some fun along the way. However, this is an educational facility, so along with the fun comes a little science and history. We'll start with science. If you know the ending of my sentence, don't raise your hand, just say it. For every action, there's an equal but opposite. Yes, I asked that last week and a kid said consequence. Look, that is correct. Wasn't what I was going for. So for every action, there's an equal but opposite reaction. This can best be described using a fire hose. Everybody in here can hold a fire hose. It's only 10, 15 pounds. I can hold a fire hose by myself. But what were to happen if I'm the only one holding on to that fire hose and I open the nozzle? I'm going to end up with my backside covered in mud and water. What happens is when I open the nozzle and the water shoots out one way, the force of that water is so great that it forces the hose and everything attached to the hose the other way. Action and reaction. Well, Dr. Goddard figured this out, and he figured if it worked for water, why wouldn't it work for fire? He thought if I shot enough fire out of the bottom of my rocket engine, my rocket's going to go the opposite way, whether it's pointing up, sideways, or even straight down at the ground. If that fire shoots up, my rocket will go down until it can't go anymore. He wrote a paper about this. Methods of exceeding extreme altitudes. Made a big splash. The New York Times read it. They hated it. They wrote an article back to Dr. Goddard stating, Dr. Goddard, you need to go back to high school. Rockets will never fly in space. There's no air for the fire to push off of to move. Now, we all know that's silly, but back then that was the common thought. Now for the history side. Any guesses as to who built the first rocket 900 years ago? Guesses? It was the Chinese. Way back 900 years ago, the Chinese were looking for a potion to last forever. What they stumbled upon was gunpowder. A little bit different than what they were originally going for, but they got some good things out of it. They found that if you packed this gunpowder in a tube, lit it on fire, it exploded. Hence, the firecracker. They messed with it a little more, found that if you packed the gunpowder really tight and left one of the ends of the tube really weak, then lit it on fire, it shot off. Hence, the rocket. Now, this was a fantastic invention for the Chinese because they had an awful neighbor to the north, the Mongols. You might have heard of them or seen them on Mulan. Nasty, mean people. They would come to their villages, destroy everything, burn down all their houses, and the Chinese, being peaceful, had no way to defend themselves. Until now. So the next time the Mongols came to town, the Chinese shot these new arrows at them. And the Mongols never seen these before. What do you think they did? The ones that were on fire ran home. And the Chinese had hundreds of years of peace. Perfect timing for this man with the name of Wan Hu to decide that he was going to go to the moon. Now, Wan Hu's first mistake, not having Google, was that he thought the moon was only 25 miles away. So, he thought if he sat in his bamboo chair there, lined it with all these new rockets, and had a servant slide them all at the same time, that he'd make it to the moon. Now, who was the first man on the moon? It was Neil Armstrong. It was not Wan Hu. Unfortunately, Wan Hu did die in the explosion. However, there is a crater on the dark side of the moon named the Wan Hu crater. So maybe a piece of him made it up there. Who knows? Now, maybe Wan Hu would have had a better shot at making it to the moon if he would have had access to this stuff. This is negative 300 degrees below zero. It's got a light blue tint, boils at room temperature. We use it every day. I hope we all continue using it, at least while we're in here. Please, nobody stop using it. Any guesses as to what it is? Yep. Acid? Yep. Way colder than that. It is oxygen. It's liquid oxygen. It's boiling right now. I can make it boil faster with just the heat of my hand. I can make it boil even faster. Just by setting it on here. This is actually so cold that if I were to submerge my fingers in there for about 5 seconds and then smack it on my board here, my fingers would pop off like a bunch of little sticks. So, it's a key component in our everyday lives. It's also a key component in one of my favorite things, fire. What are the 3 things you need to make a fire? Oxygen, a fuel source, one more. Ignition, heat. We need some heat. We have all 3 of those things in here. You guys want to make a fire? Yeah? Okay. Well, we have oxygen in the air. We have about 20%. I got some fuel. Got some cotton. It might interest you to know that in the lab where I make a lot of fire, I use cotton as my fuel. You all are wearing some form of cotton right now. Don't worry. I've never hurt anybody but myself. Yet. All right. And we got some heat. I have a match. But matches aren't fun. So I'll use a blowtorch instead. This is where you all go, ooh. Ah. Now, who thinks this is enough to get us to the moon? No? we increase? Oxygen. I can increase. What do you think? More fire. More fire? Originally, yes. Except my boss won't give me anything hotter than a blowtorch. I'm not sure why. So that's about as hot as we're going to get. But we can increase the fuel and we can increase the oxygen. Inside this cotton ball, there's about 20% oxygen. But if I were to give it a bath in the liquid oxygen, it would take this from 20% to 100. So naturally, I'm going to do it. Let that soak here. Now, you guys have all seen the Mona Lisa, right? You know how she has no eyebrows? I plan on keeping mine. Now, while I finish putting on all of my safety gear, if everyone on the benches will grab theirs, it's velcroed underneath of your seats, and please put it on. Did I forget? Yeah. We'll improvise. Can I have you guys sit up nice and tall? Sit up nice and tall. Everyone else can go over and duck behind it. I'm kidding. This is here. And like I said, it's kind of awesome. I've never heard anyone else yet. Alright. So I'm going to drain off all of the extra liquid, except liquids don't burn. And I'll explain more of that in a little bit. It makes this noise because it's evaporating the second it hits the floor. Alright, that's about all we're going to get out of there. Make sure my hair is behind my head. Try not to blink. And 3, 2.
Can we do that again?
Now, I heard someone said they did blink. Don't worry, I always do. That's why I have it on instant replay. So, it's impressive. So impressive that it went all at once. We needed that sort of force just to last us a long time. Lucky for us, science gave us the 3 states of matter. So we had about 3 different tries at it. That was a solid. Who can give me the other 2? I hear a bunch of whispers, though. I'm going to pretend like I can't hear you, so say it louder. Liquid? It is liquid. That's one. What's the other one?
Gas.
Close. Gas. Liquid, oxygen, and gas. I mean, liquid oxygen. Look at you. Solid, liquid, and gas. So we just did a solid. Let's try a gas. We're going to use the oxygen to help us out one more time. Mainly because I like playing with it. Got about 1/4 of a cup in here. You thought I was going to let it pop. Do I look like somebody that would let a balloon pop?
Yes.
Fair enough. Okay, so we have the same amount of liquid that I started with, and we have this big, we'll call it a tank. You guys think gas is enough to get us to the moon? Didn't use very much. Maybe? Yes? No? You're saying no? Guess what? You're right. It takes 3 tanks the size of Yankee Stadium to get 1 hot dog to the moon. So we really don't have the space for that. So that leaves a liquid. But I thought I said liquids didn't burn. We put gas in our cars. Let's try it. Alright, got my fancy pedestal here. Some secret rocket fuel. forcing it to evaporate faster. You look really confused. Don't worry, it's just water. But once I'm going to grab the rock bottle, it's going to make for a really poor show. Now, we don't have time to sit there and watch the evaporate on its own like that. So what if we could speed that process up by forcing it to evaporate faster? Like this. When I squeeze the nozzle, it brings water up this little tube and out these little bitty holes that separate that one drop of water into millions, increasing the surface area. Well, Dr. Goddard figured this out, so what he did was he started to poke holes in the top of his engine. This one only has one, but the one you can see out front after the show has a whole bunch of little ones. So he poked these holes in the top of his engine. Then he forced the fuel through those holes, forcing it to come out the back as a vapor, mixing with the oxygen, giving us the reaction we saw with the cotton ball, just lasting longer. Make sense? You guys want to see it? Yeah? Okay.
Oh, yeah.
Well, then go grab my rocket. It's at the Culligan Space Agency. This has everything we need for a rocket. It's got a combustion chamber, which is just a big fancy term for the space for the fuel particles and the oxygen particles to meet, have a little party. It's got a throat, which just takes this bigger area, forces it into a smaller area, giving us some acceleration, some thrust, makes it go fast. And an exhaust nozzle, which just allows a place for the particles to escape. Now, if I were to close the exhaust nozzle, I would no longer have a rocket. What would I have? A bomb. We never intentionally make bombs in Dr. Goddard's lab. There is always the occasional happy accident. Alright, so I got my secret rocket fuel. Let's see. 1, 2, 3, 4, 5. There we go, now it's coming out. Alright, who thinks we need more? You in the back says, yeah, we need more.
Yep. Lots more.
You think we need more too? Alright. That's about 10-ish. Think that's good? Yeah? Okay. Well, we're not going to launch my rocket up and down, because I don't have the space for that. But we will, however, launch it laying down. Now, praying the humidity works with us. It's going to get warm over there. Just so warm. And 3, 2.
Again?
Now, it was kind of hard to tell, but did anyone in the front row catch me covering the exhaust nozzle with my glove? You did? Do you know why I had to do that? Yeah, if I wouldn't have cut off the oxygen, it would have kept burning, and then I would eventually would have started to burn a hole right through my exhaust nozzle. Then I wouldn't be able to use this rocket again, which is exactly what was happening to Dr. Goddard. He had figured out how to use his fuel, but now, every time he lit his rocket, he was getting a hole here, and he got a hole over here, and he got a hole over here, and then eventually the whole thing would start to melt. So we had to come up with a way to cool down his rocket engine while it was still burning. So what he did was he came up with a method called curtain cooling. Curtain cooling, you have your rocket engine, and they built another chamber around it, and then the space in between filled it with the fuel itself. And there was a tube that went into that inner chamber, pulled the fuel up and out the top holes we talked about earlier, forcing it to come out as a vapor. So while the fuel was burning, it was also cooling down the engine. Nowadays, they don't use that method. They use a method called the spaghetti method. So that's what I've been told the welders call it. They take little hollow tubes and weld them up and down, all the way around the engine. And they force the fuel through those tubes, up and out the top holes. Yeah, a little bit safer and more efficient. Easiest way for the kids to understand this, you guys like water balloons, right? Yeah, well, if you fill a water balloon half full of water and half full of air, and then you light both sides of the lighter, what side's going to pop first, water or air? Air. Why? Because does water light on fire? No. So even though the wall of that balloon is so thin, that water is keeping it cool enough to stop it from popping. you guys. I'll light a balloon half full of water and half full of air. So I can get one without coughing. Alright, so I got some water. And some air. And you guys said the side with water is not going to pop, right? So do you trust me? No. I don't know why. Alright, I'll do it over here. So there's the water. Turn it a little black. Now, like I said, if I were to light it for too long, it eventually would pop. Now, do you trust me to do the air side? No. Alright, I'll do it back here. Now the side with air. Almost instantly. You were smart. So, we figured out how to cool down the engine. We figured out how to use the fuel. You think we're ready to go to the moon? No? What am I missing? When I let that balloon go earlier, did it fly straight? It went wherever it wanted. We need some form of guidance. One of Dr. Goddard's many first thoughts, a football. Everybody's seen a football, except I am lucky enough to have the official Patriots football here. It's black. Now, really not a fan. So, everyone has seen a football or has thrown one at least once in their life. When you throw a football, you have your fingers on the laces. The last thing touching the football is your finger on the laces, pulling it into that nice, beautiful spiral we love so much. Well, Dr. Goddard thought, my rocket is shaped similar to a football. When a football is spun, it flies straight. So what if I just spun my rocket to the moon? It's a great theory, until you put a human inside. Could you imagine Neil Armstrong's first words after spinning 3 days to the moon? That's one small. It wouldn't have went over well. So we went back to the drawing board, and what he came up with last was something called a gyroscope. Don't worry, kiddos, it sounds like a big word, but it is nothing more than a top. I promise. However, scientists refuse to call it a top because it only has 3 letters. So they call it a gyroscope. But it works the same way. It's got a wheel at the bottom, wheel right here, and a wheel on the inside. Now, without doing anything to it, and I spin the bottom, the whole thing moves. But if I were to energize the small inside wheel, then spin the bottom, this part won't spin with the bottom. It's going to stay in its one direction. And it doesn't move. So, what Dr. Goddard did was he put this gyroscope, or the top, in the nose of his rocket for guidance. Then he attached it to a pulley system that ran all the way back to his engine, attached to what we call blast vanes. The real ones are metal, ours are plastic. Blast vanes just surround the engine like so. Like this, if you're really fancy, like this. We're going to put them here. Then, when they want to change directions, the pulley system would just pull the blast vanes, changing the direction of the exhaust, thus changing the direction of the rocket. Now, Dr. Goddard spent the next 13 years of his life on this concept alone. 13 years. And as stubborn as that man was, he seemed to think that if you put 2 metal plates right up next to the exhaust to change the directions of that rocket, that it was going to work. Even after he came up with a cooling process for his metal engine. Do you think it worked? Nope. They busted, they broke, they melted. 13 years. Until one day, he's looking at his engine, he looks at his wife Esther, and he goes, "Hey, Esther, what if we don't use these?" That's a good idea. He said, what if we just attach the pulley system to the engine itself, making the whole engine move, like so. This process is called gimbaling. Gimbaling just allows the rocket engine to move freely, whatever direction they need. So if they want to change the direction of the rocket, shuttle. First off, you're going to see two big engines and a small one. Behind the sparks is a third big engine. Watch what happens to the back two engines after all the sparks are gone. Do you guys see him pinch? That pinch was strong enough to turn that shuttle 180 degrees after takeoff. Watching it. So they pinch, take off. All that steam is just gallons of water protecting the launch pad during takeoff. And it starts to spin, ending up on its backside. So, we figured out how to steer our rocket, we figured out how to cool down our engine, and how to use the fuel. The last thing everybody had to figure out was what type of fuel to use. Dr. Goddard used to use gasoline and oxygen. The Germans, by no surprise, used alcohol and oxygen. We used to use kerosene and oxygen. But even back in Tsiolkovsky's days, he knew that liquid hydrogen and liquid oxygen were the best match. Hydrogen is by far the most flammable and lightest of all the elements. So it even powers our sun. So you guys want to see what it can do to a rocket? Yeah? Okay, well I'm going to use hydrogen gas because I want to walk out of here, but we'll get the same effect. This rocket, it's got two holes, one on the top and one on the bottom. I'm going to tape up the top hole, and I'm going to fill the bottom hole full of hydrogen. Then I'm going to peel the tape off and light it on fire. When I light it, there's going to be a hydrogen candle. Maybe if I can get my tape, there we go. A hydrogen candle about this big. As this candle gets smaller, what's happening is all of the hydrogen is seeping out of the top hole, and all of the oxygen is coming in through the bottom. And everything condensates up, and it condensates until we get 1/10 of a drop of liquid hydrogen. And when that 1/10 of a drop of hydrogen meets with the oxygen, it is love at first sight. I promise. Now, if you have sensitive ears to sound, cover your ears when you see the flame. Alright, I'm going to fill it full of hydrogen. I'm going to stand over here. That would be why. That was 1/10 of a drop of liquid hydrogen. The space shuttle uses 300 gallons per second. That's enough to fill this room 3 times. So, the space race started, and unfortunately, Dr. Goddard died in 1945. Hot. Right about the time that Werner von Braun came over to the U.S. to help us out with our space race. So, unfortunately, he didn't get to see his inventions and his patents go into use. His wife Esther, however, did. And she's sitting at home watching everything, and she's going, that looks really familiar. That's my husband's stuff, yet I haven't received a single cent for any of it. So she goes to the government. She says, excuse me, for using my husband's stuff, I'd like my money. The government, being as they are, just said, yeah, go away. So Esther sued the government. And again, to hush her up, they gave her $1 million. Sounds like a lot of money, right? It does, until you add it all up and realize that the government used about $65 billion worth of patents from Dr. Goddard and Esther. Them only ever receiving $1 million of it. But Esther was okay with that. She took her money and she went and found every single person that ever helped Dr. Goddard his entire life and paid them their share. She even set up a couple scholarship funds because she wanted science like this to continue. Now you guys remember the New York Times article I told you about at the beginning? They told Dr. Goddard he was crazy. Well, as Apollo 11 is on its way into space, the New York Times posted an article back to Dr. Goddard. And by article, I mean sentence. It was this big. It said, Dr. Goddard, you were right, we were wrong. Rockets really will fly in space. I'm sorry. So he got his recognition, just maybe a little bit too late, but at least he got it. Now, after all of this, who was inspired to go home and be the next Dr. Goddard? okay. I never did any of those. After this, who's inspired to go home and blow some stuff up? Yeah, that's what I thought.
Everyone.
You're not going to. Make this stuff look really easy. It's not. I promise. I've had lots of training and I really do still get hurt. Make this stuff look fun. It's because it is. The only advice I can give you is if you really want to do this stuff, go home, study hard, eat all your vegetables, as gross as they are, and maybe you too can do something great one day. If you guys have any questions at all, come up and ask me. They're going to the planetarium show at 4. It's going to be here on your right, and it's going to start in about